Okay, here's another scenario that you're going to see in your homework, and this is circular permutations. So when you're arranging things in a circle, the rules are a little bit different than when you're arranging them in a straight line. And to kind of explain that, we're going to talk about a couple examples here. The first one is how many ways can 4 children be arranged on a merry-go-round? So the idea here is that the merry-go-round can spin, right? So if you spin the merry-go-round and the kids don't get off and move positions, then all of those, there's a few different positions that actually kind of look the same. So here we have these 4 children, Jane, Michelle, Casey, and Dallas, and I've just arranged them on this merry-go-round, right? So this is the first ordering, okay? So we have Jane, Michelle, Casey, Dallas, okay? But if I just spin this 90 degrees, what's going to happen is J is going to be over here, M is going to be down here, C is going to be over here, and D is going to be up here. So that's this guy right here. Okay? So that's not really a different ordering. That's pretty much the same ordering. We've just spun the merry-go-round. So we're not going to count that as a new order. Okay? Let's keep going here and look at this guy. Okay? If I turn it again another 90 degrees, the D is going to go over here, the J is going to go down here, the M is going to go over here, and the C is going to go up here. And that's what this guy is. Okay, so this is position 3. Okay? And then likewise, I spin it one more time, and Michelle goes up here, and Casey goes, sorry, I'm spinning this one, right? So Michelle goes up here, up here, Casey goes over here, Dallas goes here, and then Jane goes over here. So just spinning this 90 degrees. That's what this one represents, just this one 90 degrees rotated. Okay, and the point is, those look like 4 different orderings, but that's one ordering. This is all the same permutation. If we're talking circular, because we don't care where the beginning and the end are. It's a circle, so there is no beginning and end. It just goes around in a loop. So these count as one thing. Now, in a linear permutation, where you have everything lined up in a row, these would be 4 different orderings, right? So if I want to do a linear permutation of 4 different kids, how many different ways are there to order 4 different kids? I would just go, okay, well that's 4 factorial, right? No big deal. But the problem is, when we start talking circular, is that these all of a sudden don't count as 4 different orderings. They count as one different ordering because we're in a circle and there's no beginning and there's no end. And so what we have to do, this one would be 4 factorial, which would be there's 24 different ways to arrange 4 kids. 24 different ways to do that. But if they're in a circle, there's not 24 different ways to order them. There's 24 divided by 4 different ways for them to do that. Because for every ordering, you have 4 different positions that you have to account for that are really the same. So here, we count these all separately. Here, we count these all the same. So the only way we get a different ordering in a circle is if actually the kids get off the merry-go-round and move to a different spot, and they're not in the same, same ordering again. That's not the case over here. So whenever you see circular permutations, so things arranged in a circle, things arranged around a table, or things arranged on a circular rack, or things like that, we have to divide out the extras. We're going to get too many. If we just do 4 factorial, we're going to get more than we need. And so what we end up doing is we do 4 factorial over 4 for this situation, which actually turns out to be 4 times 3 times 2 times 1 over 4. And notice that the 4s are going to cancel. So really what we get is 3 times 2 times 1, which is 3 factorial. Okay? And that's true for, any different kind of situation. So really, this is how you get a circular permutation. You take the number of objects and subtract 1 and then do that factorial. But that's kind of the same thing as saying n factorial will give you all the different possibilities. But then you have to divide that by n, because if there's 4, in this case, there's 4 different positions, there's 4 different ways. But if there's more things, then you have to divide it by however many things there are. Okay? That's kind of confusing, so let's go jump down here and do another example. Okay, how many different ways can 12 different spices be arranged around a circular spice rack? Well, if we were just talking about how many different ways there are to arrange 12 spices, there's 12 factorial ways to do that, right? Okay, but think about how many, if you just turn the spice rack 12 times, you're going to have the same ordering. You're actually not taking out the spices and rearranging them, you're just spinning the rack. So if you do 12 factorial, you're going to get too many, because you're counting like all the different possibilities of just spinning the rack, and you need to like get those out of the way. So you have to divide by 12. There's 12 total things, so you got 12 factorial for all the different ordering, but then divide out all the different ways there are to just change position with the same ordering, because those don't count. Well, this is just the same thing as 12 times 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, right? 12 factorial over 12. Notice the 12s cancel. And so what happens in every case is you actually end up just getting one less than the number of objects you have, right? 11 factorial. Well, if you start with 12 different spices and you know you're in a circular rack, you just say, okay, 12 minus 1 is 11. I just do 11 factorial. So you don't have to go through this whole trouble every single time. You just kind of remember this guy. This is just 11 factorial. You can find out where that is. It's a big one. So we got 1, 2, 3. So it looks like 39,916,800 different ways to do that. So look for that keyword, circular, or you got a circular rack, or you got a circular arrangement, or you got things sitting around a table, or stuff like that. Because if you just do the number of things factorial, you're going to have too many different orderings. You have to divide out how many positions there are, because you get those other orderings just by spinning, and in circular that doesn't count as a different ordering.